Okay, so we're going to go over the FRQ that was assigned to you guys. We have a differential equation, dy dx equals x over y, and then they give us a constraint, y does not equal 0. So part A, we have a slope field. It says the slope field for the given differential equation is shown below. Sketch the solution curve that passes through the points 3, -1, and sketch the solution curve that passes through the point 1, 2. And then it says, note, the points 3, -1, and 1, 2 are indicated in the figure. So if you were to, let's start with the one on top here, the 1, 2 point. So if I kind of look at the curve here, it kind of looks like a parabola that kind of slopes out a little bit if I go with the wave. So I'm going to draw that in. This point down here, however, it looks like it would be like a sideways parabola. But the problem with that is it wouldn't be a function. So I'm going to draw the part of the sideways parabola that goes through my point. But I'm going to stop it right here because if I keep going, it wouldn't be a function any longer. So I'm just going to do the bottom half of that sideways parabola. And it actually gets an open circle because right at the point there, it would become vertical. So we can't include that point. Okay, so part A is worth 2 points, 1 point for each solution curve. Okay, so let's go to part B. Write an equation for the tangent line to the solution curve that passes through the point 1, 2. So anytime we need a tangent line, we need a point, which we already have, and we need a slope. So I'm going to use my differential equation to get my slope. So my slope formula is x over y. So my x is 1, my y is 2. So my slope for this point is 1/2. So my tangent line equation would be y minus 2 equals 1/2 x minus 1. Okay, now on to part C. We're going to now find the particular solution, and they say this important part right here, y equals f of x, which means we have to solve for y, to the differential equation with the initial condition f of 3 equals -1, and we're going to state the domain. So let's start by writing our differential equations down. dy dx equals x over y. Next step, I'm going to cross multiply, so y dy equals x dx, and this is pretty easy because it separated the variables for us after we cross multiply, so we don't have to worry about that anymore. Next, I'm going to take the integral of both sides. So the integral of y is 1/2 y squared. The integral of x is 1/2 x squared plus c. Now at this point, I'm going to solve for y. So I'm going to multiply by 2 next. So y squared equals, this would give me x squared plus c. And I'm going to take the square root of both sides. Now normally I need a plus or minus, but if I look at my point here, my point's at 3, -1. So up on the graph here of my slope field, 3, -1, that's this point right here. So it's the bottom half of the parabola. So the bottom half would be the negative square root. So knowing that this is going to be a plus or minus, I actually only want the negative square root because that's the part of the line that goes through our point. So I have my general solution. Next, I'm going to find my particular solution. So I'm going to plug my points in. I'm going to plug -1 in for y and 3 for x. So that gives me 9 plus c. I'm going to move this negative over. That really is just going to give me 1. I'm going to undo the square root by squaring both sides. That gives me 1 equals 9 plus c. Subtract 9, c would be -8. So my particular solution now would be y equals negative square root of x squared minus 8. Now, this one has a little extra part to it because it says state the domain, and we haven't really had to do this yet with a differential equation. So if I look at this, right, I want to think about where this doesn't exist. So I know I can't have a negative under a radical, so I got to think to myself, what number would give me 0, and then I can't have anything less than that. So I have a -8 here. I need an 8 to get this to be 0. So squaring something, it would have to be √8. The square root of 8 squared is 8. So the square root of 8 is actually our cutoff point. And it can be bigger than that, but it can't be less than that because that would give me a negative under my radical. So the domain, x has to be greater than the square root of 8.